Good morning, everyone. A little word of warning. I am under the weather this morning, so please bear with me as I clear my throat, and you might see me blowing my nose. Oh, that's fine. I'm happy to be here. So good morning, everyone. My name is Molly Alves. I'm a wildlife biologist with the Tulalip tribes in Washington State. And for the past 7 years, I've been working to protect the subsistence resources of the Tulalip tribes, which includes large game like elk and mountain goat, but also through the management of the Tulalip Beaver Project. And I'm really excited to be here today to share with you a little bit more about how and why we're leveraging beavers to restore ecosystem function for salmon in Western Washington. Next slide, please, Jackie. Thank you. So there are 5 key elements that define our project, and the first and probably most important is sovereignty. The Tulalip Beaver Project began in 2014 at a time when beaver relocation was illegal in Western Washington. And so we were and still are to this day operating under the sovereign rights of the tribe to restore and create salmon habitat within what's called our usual and accustomed hunting and fishing areas, or UNA. And we enlist beavers as partners in habitat restoration for salmon, which is an incredibly important subsistence resource for Tulalip tribal members. Now, within Tulalip's UNA lies the Mount Baker Snoqualmie National Forest, and Tulalip has a longstanding memorandum of agreement with the Forest Service, which allows us to co-manage their lands for restoration. So under this existing agreement, they agreed to be the recipients of our relocated beavers. And today we are confined to relocating beavers to U.S. Forest Service land, but we are trying to gain access to other public lands in an effort to expand the geographic breadth of this work. After a few years of relocating, our project really began to gain regional recognition and especially popularity with homeowners that wish to resolve beaver problems non-lethally. And as a result, we began to get calls from all corners of Western Washington and realized not only did we have a capacity problem, but that there was a need for a greater geographic expanse of relocators in Western Washington. So initially we began reaching out to other sovereign tribes to see if they were interested in training with us to become relocators. And we were successful with the Cowlitz tribe in southwestern Washington, who are now in their 3rd year of a relocation project. But we also didn't want the kind of time-consuming and financial burden of beaver relocation to fall solely on the tribes. And in the meantime, we were speaking with a couple of other non-tribal groups that were interested in getting involved. So we decided to attempt to amend the Washington State Beaver Bill. And in 2017, we began working with Tulalip lobbyists to change the language of that bill to include Western Washington. We gathered bipartisan support for the bill change, and we went down to Olympia and we testified in the State House and Senate. And in 2017, we were successful. The amendment was passed, legalizing beaver relocation statewide. And what happened as a result of that is the Washington Department of Fish and Wildlife was tasked with developing a pilot program to certify beaver relocators. And so for 2 years, we advised them in the development of this program. And we just finished up our 3rd year of contributing to the technical training of their certified beaver relocators. And then finally, the whole purpose of our project is to preclude the lethal management of beavers and relocate them to areas where their engineering capabilities will not only be tolerated, but respected for the innumerable positive benefits that they provide to Western Washington's suffering hydrology. Next slide, please. As we all know, and it's been stated many times over the past couple of days, beavers were nearly extirpated from the US during the fur trade. And what happened when we removed this keystone species from the landscape is we lost watershed complexity and function. Our streams became far more eroded, water temperatures rose, and we lost immeasurable acreage of wetlands. And at the same time, we were converting our floodplains into farmlands and installing infrastructure at a time when beavers were largely absent from our waterways. So as they're making their return, there's little tolerance for their dam building in now human-dominated regions. And this intolerance has perpetuated having less salmon in our streams and less resistance to disturbances like wildfire and climate change. Next slide, please. Thank you. So fortunately, we have the resources to combat a lot of these issues, and we have a partner that works for a fraction of the time and cost of most human-built restoration projects. Beavers are fortunately making a return to portions of their historic range in the US, and beaver management practitioners, a lot of whom are presenting on this call today, have been studying the effects of beaver dams. These organic creations restore stream function through increasing natural processes like sediment deposition, freshwater flow and storage, pollutant filtration. They recharge aquifers and create fire breaks, and they can also decrease the negative impacts of human activity like climate change, such as erosion and stream temperature increase. Next slide. So the Tulalip Beaver project has three main objectives. The first is determining whether or not there's actually a need for relocation. The second is sourcing beavers from areas where there's little tolerance for them and strategically placing them for salmon habitat creation and restoration. And our third and final objective is to monitor these sites for changes post-relocation to better understand the effect that these relocated beavers are having on ecosystem condition. And I think it's worth noting here, because I heard a little bit about this in yesterday's presentations, Washington does not have a formal state beaver management plan. That being said, we have worked very hard with our partnering state agencies to ensure that beavers are mentioned in most of the state's salmon recovery plans as being beneficial or essential to recovery, because those salmon recovery plans guide most of the in-stream and riparian restoration work that's happening in the state. And I'll be the first to admit, we know very little about the current population of beavers in Washington. What we do know comes from trapping records and tracking landowner complaint calls, which have drastically increased since the year 2000, after body gripping and leg hold traps were outlawed in Washington state. What happened after that is beavers began returning to lowland areas that offered more protection from predators and was full of infrastructure that was really easy to manipulate with literally just a couple of sticks. And as a result, at the time, due to a lack of management alternatives and knowledge of coexistence, they were being lethally managed at an unprecedented rate. And meanwhile, the Tulalip tribes were trying to dream up a way of addressing hydrologic issues affecting salmon on a landscape scale. And we knew that beaver dams provided excellent rearing habitat for juvenile salmon, and that many beavers were being killed due to conflict with humans, and that didn't really need to be happening. So we looked to the headwaters of our local watersheds and tried to figure out if there were portions of the beaver's historic range that they were struggling to naturally recolonize. We developed a three-step process for identifying potential beaver relocation sites. The first step was using the beaver intrinsic potential model, which was designed for us by Michael Pollack at NOAA Fisheries. And what this model does is it inputs watershed scale metrics such as gradient and stream width to identify stream segments on the landscape that have the potential for beaver occupancy and dam building. And this model ranks each stream segment from highly suitable to not suitable at all. And from there, we go out to each site that ranks as having high or medium suitability and use our internal developed site scorecard to further rank these sites for things like beaver occupancy, food and water availability. And then the final stage of our site selection is that all of our sites are vetted by United States Forest Service staff to ensure that relocated beavers won't impact park infrastructure. And Jackie, could you please click next?
Mhm.
Perfect. So in exploring this process for the Skykomish watershed, where we began this project, you see here, we found that nearly 75% of the habitat that ranked as highly suitable for beavers was currently unoccupied by beavers, which led us to believe that there must be some type of barrier, whether physical or ecological, to their upstream dispersal, and that there was actually a need for some sort of assisted recolonization of these areas. And today we've expanded these efforts to the 3 different watersheds that we're now operating in. So now we knew where the beavers were going to go, but we still had to figure out where they were going to come from. And we did not have an interest in removing just any beavers, as we recognized the benefits that we hoped for them to provide in the uplands, they also provide in the lowlands. So we began to form partnerships that would allow us to identify sources of nuisance beavers. And you'll notice I put air quotes around nuisance because beavers are a native species in Washington, and we really consider them as themselves to be a natural process that benefit natural systems. However, with the rise of unnatural human altered systems, there were areas where beavers just doing what they were evolutionarily designed to do was causing unforeseen problems. In agricultural areas, irrigation ditches are allowing beavers to build what we call high top dams that can impede salmon passage. And a recent study found beavers in nearly 86% of Seattle's urban streams, where they have the potential to plug undersized culverts and flood out access roads. And while we certainly consider this to be an infrastructure problem to a certain degree, more than a beaver problem, we've also seen cases of beavers taking out power lines or felling trees onto businesses and homes, which is certainly a valid concern. Next slide. So we began trapping these nuisance beavers from human-dominated areas where their damming activity was impacting things like culverts, roads, farms, and private homes. And I think it's really important to emphasize here that we're strictly removing beavers that are causing safety issues or are not providing ecological benefit. For example, when they're stuck in a detention pond or a roadside ditch. We partner with our local counties and their associated conservation districts who refer us to road maintenance crews battling roadway flooding, or to landowners who are experiencing beaver-related issues. And before we even consider relocation, we always perform a site assessment to explore whether in-place management or coexistence is an option. We educate landowners on the benefits of keeping beavers in place and always explain that trapping is really a short-term solution to a long-term problem. And in cases where we do resort to beaver removal, we try to establish a post-trapping plan with the landowner to ensure that their property is beaver-friendly and flood-proof for when beavers inevitably return. For this, we partner with Beavers Northwest. Hopefully some of you got to see Elisa's presentation yesterday morning. She's their director. And Beavers Northwest is a nonprofit that specializes in place management installations, such as exclusion fencing and pond levelers. But when we do trap, we are targeting entire family groups or mated pairs because beavers form very tight-knit familial bonds. And we found that they're much more likely to stay where we put them if we relocate them all together. Typically, we trap a site for 1 to 2 weeks using scent-based lures and dam notching to coerce beavers into the traps. And we use game cameras and sign surveys at the sites to ensure that all beavers are being captured. And we do identify individuals that we've captured, so we have an idea of which family members we're still targeting in the trapping effort. So post-capture, all beavers are transported to the Tulalip fish hatchery for minimal processing and to wait for relocation while we work to capture the entire family. And here they stay in hatchery raceways with flowing water and stainless steel constructed lodges. And I emphasize stainless steel because we used to use wooden lodges, and we all know what beavers like to chew on. So that was a hard lesson learned by our project over the years. To date, we've transported over 250 beavers, and these are wild animals being returned to the wild. So we try to minimize handling and avoid habituation. When they arrive at the hatchery, each beaver is weighed and given an identification ear tag, and that helps us track individuals while they're under our care, but also helps post-relocation with camera trap detections. We also determine the gender of all these subadult and adult beavers to help us track which individuals have yet to be captured, but we also occasionally capture single beavers. And in these cases, we keep them at our facility and do what we like to call a little bit of beaver speed dating to ensure that no beaver is relocated on its own. And finally, in our processing, we take a hair sample and a DNA scrub. And beginning this year, we started working with Washington State University to determine if these samples can be used with eDNA technology to not only track beavers post-relocation, but also try to determine if there's any risk of relocated beavers spreading disease or aquatic invasives. So from the hatchery, beavers are loaded into transport cages and trucked up to our pre-selected mountain streams. We set up game cameras to monitor their post-relocation activity. And beavers are highly mobile animals and do not always stay within our relocation reaches. It's impossible to collar a beaver due to their anatomy and the abrasiveness of their semi-aquatic environments. So tracking can be really difficult. That being said, we are working with a local company here in Redmond, Washington called Wildlife Computers to try to design a GPS tail mount transmitter to attach to our adult beavers to try and better understand how relocated beavers establish or move across the landscape. We get this question a lot. I would say on average, we calculate around a 30 to 40% establishment success rate, which is relatively good considering the high mobility of beavers. And since beavers are difficult to track, it's impossible to tell whether or not they're simply swimming outside of the reach that we're monitoring and successfully establishing elsewhere. We have very little to no sign of predation at our relocation sites after beavers abandon them. So we don't consider that to be a huge factor. But our assumption is that at least a percentage, we don't know what percentage that is, but a percentage of our relocated beavers that don't establish are hopefully remaining in the uplands and contributing to that ecosystem restoration, or just building genetic diversity of the local beaver population and reproducing, which further contributes to long-term watershed protection. So some challenges. Beaver relocation is certainly not a one-size-fits-all approach to beaver and landscape management. And there's ever-growing challenges in managing a project of this type. All of our work is grant funded. And while we've been very successful at obtaining a diverse array of funding sources over the years, particularly for salmon recovery and water storage. These funds are really meant to fund one-time projects with clear-cut deliverables. And as a project that defines success as having highly mobile animals remain where we put them, and also as what started as a pilot project that's developed into a long-term program upon which many now rely, we often struggle to meet our 3 objectives on an annual basis. Additionally, many of these grants often don't fund the monitoring that allows us to quantify these benefits. And we've yet to receive the capacity funding necessary to perform proper post-relocation fish monitoring. Beaver relocation is also definitely not a one-person job. We also rely on capacity funding to supply our project with the necessary staffing to carry out project objectives. So we've made some efforts to simplify our work to save on staff time. We've transitioned to paperless data collection via tablets, and we use the Memento app. I know some other folks use Survey 123. And in lieu of physical on-the-ground GPS surveys of the wetted edge of each of our 60 and growing sites, we use drones to capture aerial imagery, which allows us to track surface water changes at our sites over time. Another big challenge is the human dimension. There's still many misconceptions of beavers in these areas where they're naturally returning, and little knowledge of the benefits that they provide. Before our project gained reputation, it was actually difficult to find landowners that didn't prefer lethal management of their problem beavers. Humans also cause disturbance at relocation sites that are within proximity to roads and trails. And we still don't know to what degree recreational trapping has had an effect on our relocation areas, though we have had evidence of at least 2 families of our relocated beavers being lethally removed just below our relocation sites. And possibly the biggest challenge of all is climate change. Some of the sites that we've been monitoring for, well, since 2014, no longer have the aquatic capacity for beavers to be relocated. And we're also relocating these beavers to systems with sometimes flashy seasonal flows. So we have begun to explore the use of BDAs to prepare sites for relocations. And this has certainly led to added time and expense, but we're hopeful that in the long run, this will lead to a higher percentage of beaver retention at these sites. So when we do have the funding for monitoring, we definitely want to know what impact these relocated beavers are having. And next slide. Thank you. Over the years, we've studied a number of ecological characteristics of our relocation sites, but today, due to those staffing and funding constraints, we now focus our efforts on monitoring beaver presence and mapping surface water storage, which can serve as a catalyst for the numerous unseen benefits. But early on in our work, we did contribute to a pretty in-depth hydrologic study of our relocation sites. Next slide. For the first 4 years of our project, Dr. Benjamin Dittbrenner was studying the hydrologic impacts of our relocated beavers. He was interested in seeing if beaver dams impacted things like stream flow, temperature, and groundwater storage. And what he found was actually pretty astonishing. On average, relocation sites stored 22 times more surface water than our non-relocation control sites. And beyond that, the relocation sites stored 2.4 times more groundwater than the visible surface water. And below newly constructed beaver dams, water temperature averaged 2.3 degrees Celsius cooler than above the newly constructed beaver complex. Next slide. So to give you an example of what these relocations can translate to on the ground, here's an aerial image of a site that we call Mahoney. The polygon that you see here represents baseline or pre-relocation conditions. And using drones, we mapped the habitat, and we continue to do so at all relocation sites in the fall during low flow, pre and post relocation. So when this site was discovered in 2014, the stream was incised and it had a single age closed canopy riparian zone, and it really struggled to retain water year round. So in 2015, we placed a family of 4 beavers there. And much to our excitement, they started to build a couple of dams, and that started to slow and impound water and really began to open up the canopy at this site. And we were extremely excited until we returned the following spring to find that they had abandoned the site. And we were kind of left scratching our heads and trying to figure out how can we maximize the benefit that these beavers started. So we decided to supplement the site with a new beaver family in the hopes that they would build off of what the previous beavers had begun. So in 2017, we relocated an additional 6 beavers to this site. And not only did they maintain the previous beavers dams, but they created a network of 12 dams that reconnected historic channels and created a large productive wetland. And within a year, we had spawning salmon return to this stream. And this site now serves as rearing habitat for hundreds to thousands of young coho fry. Next slide. And this here is just a collage of what Mahoney has looked like on the ground over the years. You can see in the top left corner this channel spanning log in 2014, which has now become the backbone of a dam that averages 3 feet in height and is well over 100 feet in length. And this dam and the network of dams above it has provided the beavers with year-round protection from predators. And not only that, but all other shapes and sizes of Washington wildlife have returned to these areas where our relocated beavers have established, as evidenced by these game camera photos from our relocation sites. We monitor these sites for about a year prior to relocation using game cameras, and often don't get all that much activity on them. But after our after our relocated beavers begin to restore and diversify the habitat, we're seeing these localized explosions of biodiversity. We know that nearly 80% of Washington's wildlife rely on the cleaner, cooler, and deeper fresh water that these beaver dams are providing. So to wrap up, I have some takeaways for those that are currently involved or wish to get involved in beaver management. And I really can't overstate the importance of education and outreach. We've really begun to prioritize this more over the years. This all started with a small feature in a book some of you may have heard of, Eager, by the brilliant Ben Goldfarb. And with that exposure came a lot of new opportunities. We're now featured in Smithsonian Magazine and have an article coming out in National Geographic. And we actually just finished wrapping up with some filming for a new show called Wildlife Nation with Jeff Corwin on ABC. And these are all very exciting opportunities. I will say that the publicity can certainly distract from our own project goals on a day-to-day basis, but we see so much benefit in using the spotlight to reach a wider audience and educate people we wouldn't normally have access to about how amazing beavers are. This attention has helped not only with beaver perception, but our own project perception. It's helped us garner support from partners and funders and created a platform for sharing our own knowledge and skills with other beaver management practitioners. And this has also connected us with many of our project partners who are essential in our day-to-day operations and who contribute more beaver management options outside of our own scope. Secondly, I want to stress don't forget to dedicate time to put in necessary groundwork when starting a beaver management project. People that love beavers are often eager to get involved, but you really need to take time to build your network and find funding that allows you to put in the time necessary to carry out proper beaver management. And don't forget to ask for support when it's needed. The beaver community truly amazes me in how collaborative it is. And to sum it up, when allowed to remain or strategically relocated, beavers create and maintain wetlands on a broad geographic scale. Beavers are far more effective and cost-efficient ecosystem engineers than us and should be considered our partners in restoration. And beaver dams store, cool, clean, and slow fresh water, which is good for humans, fish, and all other wildlife. And beavers create fire breaks and ecosystems that are more resilient to the effects of climate change. And I am very hopeful that this video on the next slide will work.
Okay. Oh, a blank.
Looks like a no.
Looks like a no.
All right, well, I can try and describe it. It's game camera footage from one of our relocation sites, and what you would be seeing is a newly constructed beaver dam with a bobcat very patiently waiting on it. And we've kind of clipped a few videos together because the bobcat actually sat on that dam for about 3 hours before pulling a salmon out of the pond above that newly created beaver dam that was about the same body length as the bobcat, and then it carries it up a tree. So it just kind of proves that this project is doing exactly what we intended for it to do.
Wow, cool story there.
Thank you. And if you go to my final slide, Jackie, that just has my contact information.
That is the last slide that I've got, is this one right here.
Oh,
so you could
I can put it in the chat.
In the chat.
Yeah.
Wow, thank you so much, Molly.
Yes, thank you guys very much for bearing with me. Thanks for listening. I want to thank our project staff, our collaborative funders, our collaborative partners, and I will put my information in the chat in case anyone has any questions after the call today.